In this video, I'm going to be showing that the opposite angles of a parallelogram are congruent, that property, and I'm going to start in the algebra and graphics view. So I'm going to begin by creating a parallelogram. So I'll start with a line tool, and then I'm going to create a point underneath that line and make sure these two opposite sides are parallel. This is what a definition of parallelogram is. And then I'm going to create another parallel line here and intersect them using the intersection tool, and then use my polygon tool in the counterclockwise direction. So what we're going to be doing in this video is we're going to be proving the property that the opposite angles are congruent. Just clicking on this angle button, you'll see that it is true, but that isn't going to be a proof, it just shows that it's true. So let me prove it for you. And I'm going to go into my geometry view, and I'm going to bring back my segments because I just hid them temporarily. So let's prove this. The opposite angles of a parallelogram are congruent. So the opposite, both pairs of opposite angles are congruent. So we're going to prove that in a parallelogram. So we're going to do a two-column proof. And let's begin by writing statements and reasons. And reasons. And what we're given is a line of every proof is given. And we're given parallelogram ABDC. So I'm just going to move these letters out so you can see them a little bit better. So pair ABDC. Next thing that we are going to do is the very next line of every parallelogram proof is definition of a parallelogram. And that is that the opposite sides are parallel. Don't forget we are using Geogebra, so I can just show you that using the slope tool. If I clicked on the slope, the opposite sides are going to have the same slopes. In this case, they're both 0. This is a construction. I can move this and it'll always be true. But I'm just showing you that just is true, but I'm not going to be using that in the proof. I'm just going to mark the opposite of parallel using the pen tool. Oh dear, it didn't like me, so let me try that again. The opposite sides are parallel. This is how you mark that using these parallel double lines. Kind of looks like little birdies going one direction. Now, to prove that both pairs of opposite angles are congruent, we are going to do a construction. And what we're going to construct is we are going to extend the sides of the parallelogram. So let me write that down. And I think the easiest way is just hitting the line tool. And of course it's going to look a little bit messy with this proof below, but that's okay. So what we are going to be doing is proving these opposite angles are congruent. So let's mark these angles by number. So we're going to be proving that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So that's what we need to prove. We're going to mark this angle as 5 and 6. So because these are parallel, 5 and 1 happen to be alternate interior angles. So let me write that down. Angle 5 is congruent to angle 1 because of alternate interior angles. Similarly, 6 is alternate in interior angle to 4, so we will write that down too. Those are alternate interior angles. And since they're both they're alternate interior angles, now we have another corresponding angles. This is my favorite proof. I just want to let you know because I don't use triangles, I just use these line properties, corresponding angles. So where are my corresponding angle pairs? Angle 5, see it's on the lower left, on this first line right here, it's in the lower left quadrant, so it's going to correspond to angle 2. But I'm going to undo that because it's going to mix up all my markings. So angle 5 is congruent to angle 2. Because they're corresponding angles. Similarly, we have these corresponding angles too. 6 is in the bottom right, corresponds to angle 3. Now because angle 5 is congruent to angle 1 and angle 5 is congruent to angle 2, they're both then 1 and 2 are congruent to each other by the transitive or substitution property. So let me write that down. Angle 1 is now going to be congruent to angle 2 because they're both equal to 5. And also, we can say since 6 is congruent to 4 and 6 is congruent to 3, we can say these two are equal to each other. So let's write that down. Angle 4 is going to be congruent to angle 3. And the reason for that is the transitive or substitution property. And that actually finishes our proof. It's a very quick proof and it's a lot of fun. Thank you for watching.